Hey students, so welcome back to Mr. Chen's channel. So this one, today I would like to talk about the polar coordinate. So this one is the sections 8.1 from the James Stewart pre-cal. Okay, so check it out. So this one is about the polar coordinate. So it's the same as sections 8.1 from the pre-cal textbook. So one thing I just want to talk about in general, the way to convert things from polar to rectangular or rectangular to polar. So formulas that you need to recognize the structure. So let's say we do have going back to the unit circle. So we do have an x-axis, the y-axis. So let's say we do have a unit circle. Okay, so let's say that we do have a right triangle in the first quadrant. So this one is x comma y. Here's the radius, here's x, here's y. It's a right triangle with theta. So one thing that we notice, so cosine of theta, it's considered x over r. And then sine of theta, it's considered y over r. So using those ratio. So in other words, r squared is considered x squared plus y squared. Well, before we do that, so let's start it off with r equals, okay, so r cosine of theta. So try to cross multiply. So try to cross multiply this one. We do have x equals r cosine of theta. And then over here for sine of theta, so y equals r times sine of theta. Okay? So one thing that we notice, so this one is the proof that I showed you before for that the unit circle. So the way to convert that from polar to rectangular, so polar is always given as r theta. So the way to convert this one back to x comma y, so x is just consider r cosine of theta, and then y just r sine of theta. So rectangular form, polar to rectangular form. So polar form to rectangular form. And what about the other way around? Rectangular form to polar form. So the way to do it, so we do know that r is considered square root of x squared plus y squared. And then if you put in the ratios, so y over x, so we do have r sine of theta over r cosine of theta. So in other words, it's considered tangent of theta. So once you try to solve for theta, so it's just the inverse of tangent of the ratios of y over x. Okay, so the formula that I need to know, the way to convert things back and forth. So going back to the template, so what we have here, so plot the polar coordinate and give 2 additional points in the polar form for each point. So 0 pi over 2, so that means radius is 0. The angle, the direction, it's considered pi over 2. So pi over 2, which is over here, but the radius is 0. So just right here at the pole. Okay? So if that's the same position, then this one could be considered, the other point, it could be considered 0, 3 pi over 2. And also this one could be considered 0, negative pi over 2. Because that, for the direction, we can go either by clockwise or counterclockwise. You see that the margin here, the unit, it's like 1 radius, 2 radius, 3 radius, 4 for the radius, and then 5 for the radius, the unit. So what about the next one? Root 2. So r is radius, and then the direction is 3 pi over 4. So 3 pi over 4, it's all the way over here. Okay, for this directions, going around. And then the radius is root 2. So root 2, it's greater than 1, but it's less than 2, so somewhere over here. Okay, so for that polar coordinate. So start with the polar axis, the x-axis, and then all the way to over here, the terminal. So that's just the point. There's no need to connect that from the pole. Okay, because that shows the directions. Like that. if you start at the polar axis. And then the other way to find out the other point, which is the exact same position as this one, so this one could be considered root 2, comma. If that's going by clockwise, so this one would be considered negative 5 pi over 4. And also this one could be done by using negative radius, so negative root 2, reflection, and then going by pi over 4. Because pi over 4 is supposed to be all the way over here, but once you reflect it over with a negative, so it's going back to quadrant 2. And also this one could be done by another position as well, so then that being negative root 2, and also this one 7 pi over 4. So 7 pi over 4 is all the way over here, but due to the negative for the reflections, so go back to quadrant 2. Okay, so for C, so try to do that one. Again, it's all about plotting the point for the polar coordinate. So for number 2, it's quite similar. 3 polar coordinate representations for the point, which has a rectangular coordinate, negative 2, negative 2. So 3 polar coordinate for that point is negative 2, negative 2. So going back to this one, so for negative 2, negative 2, so we do know that it's in quadrant 3 for the xy coordinate system. But now it's in polar form. So polar, so you want to convert that to r theta. So we know this one's x comma y. So started with the radius, so square root of negative 2 quantity square plus negative 2 quantity square. So we do have square root of 4 plus 4, which is root 8, so 2 root 2 for the radius. And then for theta, using the inverse of tangent of the ratio, negative 2 over negative 2. So since we do know that it's in quadrant 3, so this one is inverse of tangent of 1. So try to do that on a calculator or just do it mentally, just like pi over 4. But don't forget, it's in quadrant 3. Quadrant 3, so that means what? 5 pi over 4. So for the polar one, this one is considered 2 root 2, 5 pi over 4. So again, using that, the polar coordinate, so start at the polar axis, so this one 5 pi over 4 unit, and then the radius, 2 root 2. So here's 1, here's 2, 2 root 2 is a little bit longer, somewhere over here for that point. And also express that with the other polar coordinate. So this one can be done by 2 root 2 and then using the negative radian. So then that means it would be negative 3 pi over 4 going by clockwise. And also this one could be done by using the negative radius, negative 2 root 2, comma. Again, negative, that means the reflections over the pole. Okay, so it used to be what, pi over 4? Pi over 4, it's over here. But once you reflect it, so it's going back to this one. Like that. And then what else could that be? Another representation. This one could be done by using negative. So we got a positive radius, negative radian. Negative radius, positive radian. And this one also could be done by negative negative. So let's say we go by negative 7 pi over 4 and then negative 2 root 2. So it's like a 3 different way to rewrite that, the polar point, the polar coordinate. Okay, so now let's go back to template. And then for number 4, convert the rectangular coordinate to polar. Use both r and negative r. So that one's quite similar to what we did. And number 3, so r theta. So convert the following point from polar coordinate to rectangular. So using the structure, so solve for x, y. So r cosine of theta, and that'll be x. So that means it's 3 cosine of 5 pi over 6. So then that'll be 3 times negative 1/2. So negative 3/2. And then for y, for this point, r sine theta, which is 3 sine of 5 power 6. Oh, you know what? 5 power 6. Power 6 is actually considered 30 degree. So that one's supposed to be 3 times negative root 3 over 2. Let me fix that. Negative root 3 over 2. So this one should be considered negative 3 root 3 over 2. And then 3 times sine of 5 power 6. So 3 times 30 degree in quadrant 2. So 1/2. So 3/2. So for the xy coordinate, this one here is considered negative 3 root 3 over 2, comma, 3/2. So that one's for number 3. Okay, so number 4 is quite similar to what we did for number 2, so check that out. And now the rest of this that I would like to talk about next, then that'll be number 5 and 6, converting things back and forth. So convert each equation from rectangular to polar, solve for r. Okay, so let's do that. Okay, so I'll put it out here. So also try to refer back to the other video, the lesson that I put out there for the PowerPoint presentations, 8.1. So that one, it shows the fundamental concept, the way to convert things back and forth, and also the way to plot points for the polar coordinates. Okay, so now for number 5a, okay, let me just make this one bigger. So 5a, we do have a slope-intercept form. So we do know that y is considered r sine theta, and then x is considered cosine of r cosine theta. So basically just replace that y and x by using those polar coordinate. So we do have r sine theta equals r cosine theta. B, just leave it as the way it is, but don't forget about that a right here, a times r cosine theta. So this one you want to solve for r by itself. So for the r term, just take that to the left hand side. So a times r cosine theta, so that equals b. So for r factor, take that r out as the greatest common factor. So we do have sine theta minus a cosine theta, so that equals b. So solve for r, so r equals b all over sine theta minus a cosine theta. And then for part b, it's quite similar, but before you do that, you probably want to convert, you want to complete the square first. So it looks like that one's going to be the equation of a circle. So x squared, back to the conic, complete the square, group the like terms, group those like terms. So add 1 here, add 1, so that means the other side we need to add 2. So x minus 1 quantity square plus y minus 1 quantity square, so that equals 2. Okay, so that's the equation of a circle. So back to the equation of a circle, so we do have x minus h quantity square, so plus y minus k quantity square equals r square. So we do know that 2 would be the radius square. So x here, it's considered, well, let's just rewrite it, h comma k. So x, simply use that, the r's. Okay, so we got root 2 cosine of theta. Well, this one can complete the square, so that would be a conic sections. But the center, it's right at 1 and 1, okay? So another way that I can convert this one, so let's see what's the other way to convert it. So I'll probably just rewrite everything in terms of sine and cosine first with r. Okay, for those who might be wondering, would that be easier to solve for r? We can always do that. If try to convert that with the completing the square form, xy, so then that'll be a little bit more complicated. So let's try the other way around. So let's say that this one is r cosine theta, quantity square, and then r sine theta, quantity square, minus 2 r cosine theta, minus 2 r sine theta, so that equals 0. So one thing that we notice, so once you take out r square cosine of theta, cosine square of theta, plus sine square of theta, so then that'll be considered 1. And then over here, take out negative 2r, so we do have quantity of cosine of theta minus sine of theta. Okay, so sine of theta, so that equals 0. So this one is showing that r squared minus 2r times the difference of, well, this one negative negative, so then that'd be plus. Cosine theta, sine theta, so that equals 0. So r is just the variable, so this one, yeah, from here you want to solve for r, so you probably have to complete the square for this. Okay, so think about the way to complete the square. Okay, so r squared. So complete the square, so we need to divide this 1 by 2, the coefficient by 2, and then quantity square, so it's 2 quantity cosine of theta plus sine of theta divided by 2 quantity square. So this one would be written as r squared minus 2r cosine of theta plus sine of theta, the quantity. So this one reduce, so then that'd be cosine square of theta plus 2 cosine theta sine theta times sine theta plus sine square of theta. It's like a binomial expansion. So that one is 1, it's like 1 plus 2 cosine theta sine theta. Okay, quantity square. So try to do it this way, so this one would be a little bit confused. Okay? So once you factor it, so it's like r minus the quantity of 1 plus 2 cosine theta sine theta, and then the whole quantity square. It's like completing the square. And then the rest of that, you want to expand it, put it out, and then solve for r. Or from here, you can take the square root both sides. So square root both sides, so we do have r equals 1 plus 2 cosine theta sine theta. So this one is just the double angle identity, so it's 1 plus 2 sine of 2 theta. So try to do it this way. Okay? So b is a little bit complicated. And then what about for x here? So this one is just like r cosine theta equals negative 1. So in other words, it's like r equals negative 1 over cosine of theta. So negative secant of theta. And then this one, using the structure for d, r squared. Okay, let me just clear all this annotation. Okay, so for this one, it's r squared equals xy. Xy is just like r cosine theta, r sine theta. So we do have r squared equals r squared cosine theta, sine theta. So bring everything together to one side. So a lot of people just thinking about that divided by r squared, but don't do that because you'll get rid of the r squared. Bring everything together. Take out greatest common factor, r squared. So we got 1 minus cosine theta, sine theta. So that equals 0. And then this one's a little bit interesting. So it looks like Okay, so that just shows the factor. You want to solve for r squared. So perhaps taking the square root both sides. So r squared equals 0 divided by, well, basically this one is showing that. So r squared equals 0. So using that, the property, so let's see factoring. So this one, r squared, because we want to solve for r squared. Okay, so that means 0. So r equals 0. So regardless what happened over here. Convert the polar equation to rectangular coordinates. So r equals 2. So that means this one is showing that square root of x squared plus y squared equals 2. Convert that to polar coordinate. And then this one, square both sides, so x squared plus y squared equals 4. Conic sections, equation of a circle. Theta, so inverse of tangent, or inverse of tangent of negative pi over 4, so that equals y over x. So tangent of negative pi over 4, then that would be negative 1, so negative 1 equals y over x. So that means y equals negative x after you cross multiply. So 2 cosecant of theta equals r, so 2 over sine of theta equals r. Cross multiply, so we do have 2 equals r sine theta. So that means 2 equals y, equation of a line. R squared equals cosine of 2 theta. Okay, let's take a look at that for the last two, getting more complicated. So again, r squared just like x squared plus y squared. So cosine of 2 theta, so using the identity, so we do have 1 minus, or using the cosine square of 1. Cosine square of theta minus sine square of theta. So this one is like r, let's see, cosine of theta, it just consider x over r, quantity square, minus y over r, quantity square. So what we can do here, we can just group them. So r squared, 1 over r squared times x squared minus y squared. And then the other side, x squared plus y squared. So in other words, this one is showing that r squared, it's like x squared minus y squared over r squared, just replaced it by x squared y squared. So things that we can cross multiply. Okay, so x squared plus y squared, quantity square equals x squared minus y squared. Okay, so this one basically can just leave it. Okay, no need to solve for anything. And perhaps this one looks like we can complete the square. But this form here, so since you convert that into x and y, just leave it. Okay? So what about for e? So e is 1 equals 2 r cosine theta all over r sine theta plus 3. So r cosine theta, that's x. R sine theta, that's y. Cross multiply, so we got y plus 3 equals 2x. So y equals 2x minus 3. It's a line. So one thing I'm thinking about for the other one, so 2xy. Yeah, I try to expand it for d, but it just makes it more complicated. So this one, just leave it. Okay, so that's it. So thank you for watching the video today. So make sure that you go back to another video too. So check it out, the fundamental concept of polar coordinates. Okay, so I'll see you guys next time. Have a great one. Take care, guys.